And again, welcome to our video lesson. And our topic for today is all about factor theorem. So before we proceed to our lesson proper, our objective for today's video lesson is for us to determine whether a given x minus r is a factor of a given p of x or a given polynomial equation. So by definition, mathematically speaking, the polynomial p of x has x minus r as a factor if and only if p of r is equivalent to 0. So, last time we discussed all about the remainder theorem, and if the remainder is 0, then our x minus r is a factor of the given p of x. So for this video lesson, let's have two examples. So the first example is x minus 1 a factor of 3x cubed minus 8x squared plus 3x plus 2. So again, we can use either the synthetic division method or we can use the substitution method. Either way, you can use both for you to check whether x minus 1 is really a factor of the given polynomials. For this example 1, we will use the substitution method. So again, first step is to find the value of r, or equate x minus 1 to 0, and of course we will get x is equivalent to 1. And then we just simply substitute 1 to all the values of x in the given polynomial. So p of 1 is equivalent to 3x cubed minus 8x squared plus 3x plus 2. And then substitute. 3, you substitute 1 minus, substitute 1 again, plus 3 times 1 plus 3. So we simply substitute 1 to all the values of x. So 1 cubed, that's 1 times 3, which is 3 also. So 1 cubed, 1 times 3, that's 3. 1 squared is still 1 times negative 8. That's negative 8. 3 times 1, that's 3. And then copy 2. So simplifying this one, 3 minus 8, that's negative 5. Plus 3, that's negative 2. Plus 2, that's 0. Or this will become 3 plus 3 plus 2, that's 8. Minus 8, which is 0. So in here, after substituting the value of x, we arrive at the answer 0. So to answer the question, is x minus 1 a factor of 3x cubed minus 8x squared plus 3x plus 2? Yes, x minus 1 is a factor of 3x cubed minus 8x squared plus 3x plus 2 simply because the remainder is 0, or our p of r is equivalent to 0. So to simply put, when a given x minus r is divided by a given p of x, we can say that it is a factor when, if and only if, the remainder is 0 or p of r is equivalent to 0. That's why we discuss first the remainder theorem. So let's go on to our second example. Example number 2. Is x minus 3 a factor of x cubed minus 2x squared plus x plus 6? In this example number 2, in here we use the substitution method. In here, let's use the synthetic division. So, get the value of x. So this is x minus 3 is equivalent to 0, or x is equal to 3. So we will be using 3. Copy the numerical coefficients 1, negative 2, positive 1, and then 6. And then just perform the process in using synthetic division. Bring down 1, you multiply it, that's 3. You add negative 2 plus 3, that's positive 1. You multiply it again, that's 3. You add, that's 4. You multiply it, that's 12, and this is 18. So, to answer, is x minus 3 a factor of x cubed minus 2x squared plus x plus 6? The answer is no. x minus 3 is not a factor of x cubed minus 2x squared plus 6 plus x plus 6 simply because the remainder is not equal to 0. Our remainder here is obviously 18. So x minus 3 again is not a factor of x cubed minus 2x squared plus x plus 6. So to summarize our topic all about factor theorem, we need to apply what we have learned about the remainder theorem. And what is that? If a given polynomial when divided by x minus r and the given the remainder is 0, then it is considered a factor of the given polynomial when you have a remainder of 0. But if you arrive at a remainder that is not 0, then obviously it's not a factor. So again, by definition, the factor theorem, the polynomial p of x has x minus r as a factor if and only if p of r is equivalent to 0, or if the remainder is 0. If the remainder is 0, it is a factor. If the remainder is not 0, then it is not a factor. So again, thank you all for watching. Again, just like what I'm saying, never stop learning. God bless.